Hello folks and welcome back. Today we're going to be covering section 6.4, which covers rational exponents. Remember, a rational number is just a number that can be expressed as a fraction. Now before we get into this, we're going to need to make sure we have a solid understanding of both our rules of exponents as well as our rules for fractions. So I'm going to give you a minute here to fill these out, then we'll cover these. All right, anything raised to the 0th power, x to the 0th power, is just going to be 1. If you have two numbers of the same base being raised to different powers and they're multiplied together, multiplication means we add the values. So x to the n times x to the m is x to the n plus m. If we divide these two numbers, x to the n divided by x to the m, we're going to subtract our exponents. So this will be x to the n minus m. If it's a negative exponent, we move it into the denominator or into the numerator if we start. So we flip which part of the fraction it's in, and our exponent becomes positive. Then, if we have two numbers both being raised to a power, the power goes to both. So ab to the n is the same thing as a to the n, b to the n. And if you have a power raised to a power, x to the n to the m, this is when we multiply. This becomes x to the n times m. Finally, even if you're dividing, a divided by b to the n, the nth power goes to both the numerator and the denominator. Finally, let's refresh ourselves on fractions. If we have two numbers, two fractions that are being added together, something like 1/2 plus 1/3, we need to make these into the same denominator. They just need to have like denominators. So to do this, this would become 3/6 plus 2/6, and then we would combine. So this would be 3/6 plus 2/6. We combine the numerators, or the tops, we leave the denominators alone. So this would be 5/6 as our answer. Same thing if we're subtracting, we need like denominators. So we go for 3/6 and we go for 2/6. And again, we just deal with the numerator, we leave the denominator alone. We do 3 minus 2, or 1/6. If we have two fractions that are being multiplied together, the tops multiply together and the bottoms multiply together. So 1/2 times 1/3 becomes 1/6. And then finally, if we're dividing is the same thing as multiplying by our reciprocal, or keep, change, flip. So 1/2 divided by 1/3 would be the same thing as 1/2 times the reciprocal of 1/3, or 3/1. Same rules for multiplying, we just multiply top and bottom. So our answer here is 3/2. Now the key concept for today, you can write any radical in the equivalent form using rational or fraction exponents. So we can rewrite radicals in equivalent forms using rationals or fractions as exponents. Now, how does this work? Let's go ahead and take a look. Let's say that we have 216 to the 1/3 power. The 1/3 power, the number in the denominator, or the 3, tells us our root. So this is equivalent to the cubed root of 216. So this is the equivalent to the cubed root of 216, which means we can do this one of two ways. We have two different ways to do this. The first is we say we're looking for the cubed root of 216. Now I just happen to know that 6 cubed is 216, so this would be the same thing as saying we're looking for the cubed root of 6 cubed, at which point we have a cubed root and a cubed, those would cancel out and our answer would be 6. The other way you can do this is you can leave this as a fractional exponent. We can say that this is 216 to the 1/3. We know 216 is 6 cubed, so this would be 6 cubed to the 1/3. And we have a power raised to a power here. We have a cube to the 1/3. We multiply those together, so this would be 6 to the 3/3, or 6 to the 1. Okay. Let's do another one. We have the cubed root of 8. So we could rewrite that as the cubed root, and we know 8 is the same thing as 2 cubed. And we have a cube and a cubed root, so those would cancel out. We're left with 2. Or, the other way we can do this is we know a cubed root is the same thing as the power of 1/3. So this is the same thing as saying this is 8 to the 1/3 power. Our index of any radical becomes the denominator of our exponent, and vice versa. If we have a denominator, a fractional exponent, the denominator becomes our index of the radical. So 8 to the 1/3 would be the same thing as 2 cubed to the 1/3. And we have a third power raised to the 1/3 power. That's the same thing as multiplying them, so this equals 2. Let's have you do this last one. We have the 4th root of 16. What would this be as a fractional exponent? And then try to simplify it. If we have a 4th root, the index becomes our denominator. So this would be 16 to the 1/4. And now if we do this, we're thinking what number to the 4th power makes 16? That would be 2. So this would be 2 to the 4th to the 1/4, or that would just be 2. We could still do this using our 4th root as well. That would just become the 4th root of 2 to the 4th, and then our 4 and our 4th root would cancel. Now we have a very important reminder for you here, which is when you're multiplying exponential expressions, you need like bases. So if you're multiplying exponential expressions, you need like bases. So you can combine something like 2 to the 1/3 times 2 to the 1/2. That would just come out to be 2 to the 1/3 plus 1/2 by our rules of exponents. However, we can't multiply these together if they don't have the same basis. So even if we have something like 2 to the 1/2 times 8 to the 1/2, even though these have the same power, they don't have the same base, so we can't combine them. The flip side is true if we're multiplying radical expressions. When we're multiplying radical expressions, we need like indexes or like powers. So we could combine the cubed root of 3 times the cubed root of 4, or the cubed root of 4. Cubed root of 3 times the cubed root of 4, we can just combine, so this would be 3 times 4 inside a cubed root, or the cubed root of 12. However, we cannot combine the square root of 3 times the cubed root of 3. These don't have the same indexes, or they don't have the same powers. So we're going to go look through a couple of examples, determine whether they should be written as radicals or exponents in order to be combined. In this first one, we have 5 to the 1/4, and we have 125 to the 1/4. So we have different bases here, but if we wrote these as radicals, this would be the 4th root of 5 times the 4th root of 125. Remember, all we do is we take our denominator and make it our index. Now these have the same index here, meaning that we can combine them. This would be the 4th root of 5 times 125, or that would be the 4th root of 5 times 125 is going to give us 625. So this would be the 4th root of 625. 625 just happens to be 5 to the 4th. So that's the same thing as just 5. Okay, for the second problem, we have the cubed root of 10 and we have the fourth root of 10. We have different indices here. We have different powers of roots, so we can't combine these. Let's try flipping them into fractions. This would become 10 to the 1/3. We take the index and make it the bottom of our fractional power. And then we'd have times 10 to the 1/4. Now these have the same bases, so we can combine them as like bases. This would be 10 to the 1/3 plus 1/4, which we'd then have to convert into like denominators. So this would be 10 to the 4/12 plus 3/12. So our answer for this would be 10 to the 7/12. Or if we wanted to simplify this, we have a 12 in the denominator. We could make that a root. This could be the 12th root of 10 to the 7. That's another way that we can write this. Right, now moving on, we have a question for you. Does the square root of x cubed, is that equal to x to the 2/3 power or x to the 3/2 power? We're going to use our equivalents. We're going to use all of our exponent rules to try to figure this out. So the square root of x cubed, that would be the same thing as saying x cubed, and then the square root we could write as the 1/2 power. So if we combine these, this would be x to the 3 times 1/2 power, meaning that if we have powers, they stay in the numerator of our power, and any radicals become the exponent, or become the denominator. So this would be x to the 3/2, not 2/3. Now let's go ahead and have you try a couple of these. We're going to be switching from radicals into exponents or exponents into radicals. Try problem 1 and then we'll do problem 3. What is the fifth root of x to the 7? The fifth root of x to the 7 would be the same thing as x to the 7 to the 1/5, or that would be the same thing as x to the 7/5. Similarly, the eighth root of x to the 9th would become x to the 9/8. But what about x to the 6/7? What would that become? X to the 6/7 is the same thing as x to the 6th to the 1/7 power. Or we have a 7 in our denominator, that would make this the 7th root of x to the 6th. This last one here, 4, would be a little trickier just because we'd have to convert this into a improper fraction first. X to the 1 1/3 would be the same thing as x to the 4/3, which would tell us that this is the same thing as the cubed root of x to the 4th. Okay, now moving on, let's look at negative exponents. So let's say we had something like y to the negative 2.5. This is the same thing as saying this is y to the negative 2, and 0.5 is 1/2, or that's the same as y to the negative 5/2. Now what do we do with negative exponents? We have to move them into the denominator. So instead of writing y to the negative 5/2, we'd write this as 1 over y to the 5/2. And then from here, we're just going to try to simplify. So 5/2, we know that's going to be the square root of y to the 5th. So y to the negative 2.5 is the same thing as 1 over the square root of y to the 5th. But we're not finished here, because y to the 5th we can break into something that can get pulled out of the square root, y to the 4th. 4 is a multiple of 2, so we can cancel that, times y. So this would be 1 over y to the 4th times y. Okay, square root of y to the 4th. Square root is a 1/2 power, so 4 times 1/2, that would give us 1 over y squared. 4 times 1/2 times the square root of y. And you may be thinking we're done. This is simplified here, but it's not quite, because we still have a square root in the bottom, so we need to rationalize here. So we need to rationalize. When we do that, we have 1 over y squared to the square root of 5, and we need to get the square root of y out of the bottom. How do we do that? We multiply by the square root of y on top and bottom, so that when we do that, we're left with a square root of y on the top, and we have a y squared, and we have the square root of y squared. So that's just going to be y in the denominator. Or our simplified version of y to the negative 2/5 would be the square root of y over y cubed. So a lot of steps here. First is to convert into an improper fraction, flip it into the denominator, and then try to simplify. See if we can pull any of the powers out of the root, and then rationalize. That's how you get to your answer of the square root of y over y cubed. Another thing that we can do with these rational powers is we can simplify complex radicals. So if we had something like the fourth root of x cubed divided by the eighth root of x squared, we wouldn't know how to approach that previously. But let's try changing these roots into our powers. The fourth root of x cubed would become x cubed over 4, and the eighth root of x squared would become x to the 2 over 8. Now all of a sudden, we have two powers of x to different powers divided. We know how to deal with this. We have two powers, x to the n divided by x to the m. We subtract those powers. So this would become x to the 3/4 minus 2/8. And then from here we can just simplify. 2/8 is the same thing as 1/4. So we have x to the 3/4 minus 1/4. That would be the same thing as x to the 2 over 4, or x to the 1/2, which we could also rewrite as the square root of x. Now we're going to have you all practice doing some multiplication and division using radicals. Let's start out by having you do the cubed root of 3 times the fourth root of 3. So the cubed root of 3 times the fourth root of 3, this would become 3 to the 1/3 times 3 to the 1/4. We have two powers multiplied together, so we're going to add them. We have 3 to the 1/3 plus 1/4, or that's the same thing as 3 to the 4 over 12 plus 3 over 12. Got to get those like denominators here. So this would become 3 to the 7 over 12, or that's the same thing as the 12th root of 3 to the 7. Okay, what about the square root? Remember, anytime we're dealing with a radical without an index, that's a square root of x cubed divided by the cubed root of x squared. First step here would be to flip these into fractional exponents. So this would be x to the 3 over 2. We take that second index, turn it into our denominator, divided by x to the 2 over 3. From there, we can just simplify. We have two powers being divided. We have the same base. So that's going to mean we subtract them. This would be x to the 3/2 minus 2/3. And then we just need a like denominator. So this would be x to the, let's see, multiply by 3, that would be 9 over 6 minus 4 over 6. And then when we simplify, 9 minus 4, that'll give us x to the 5 over 6, or that's the same thing as the 6th root of x to the 5th. And that, folks, is all we have for our lesson today. Remember, your indexes of your square roots, or your roots, become your denominators, and your denominators of your powers become your roots. Go ahead and get started on that homework.